Good afternoon, everyone. So we are looking at rational inequalities. So how are you going to be dealing with your rational inequalities? So firstly, there is an important rule. So we are going to answer these three problems. There's an important rule. Like for example, if you have, let's say a negative 1 is less than, let's say negative x is less than a 2. So how we get rid of this is that we need to divide a negative 1, divide a negative 1. Now immediately we divide a negative 1, it will be x. Then this sign will change. It will be facing the other side. So x is greater than a 2 divided by negative 1. It will be a negative 2 like that. So if this is the case, the same approach can be true if you have negative x is less than your, let's say, 2. But this time, let's say you multiply negative 1 on both sides. Whatever you do on one side, do it on the other. So our negative 1 times x, negative x, it will be x. Then this negative times that, this sign will change to be like that. It will be less than negative 2. Now, due to this problem, we cannot be able to cross multiply if we don't know the value of x. So as long as you multiply an inequality by negative, or an inequality you divide or multiply by a negative, this tends to change. So therefore, let's answer now. Let's say we have our question, which was saying that, let's begin with the one that was saying that 1 over x. So let's say we have this problem. Now I know many of you are smart, so please don't cross multiply. That is what might be your first approach. Now the reason why I introduced the concept of when you divide negative x is equal to negative 2 for the inequality, what happens is that the sign tends to change. So now, due to that factor, we are not going to be able to cross multiply because look, we have 1 over x. We don't know what the value of x is equal. So let's say you want to cross multiply and say that 1 is less than x times 6, it will give you 6x. This might not be true because we don't know the value of x. If let's say, for example, the value of x is equal to negative 1, then we are going to have 1 over negative 1 should be less than 6. But immediately we do this, we are going to find that our 1 should be greater than our, since we are multiplying by negative times 6, the sign will change to be something like this. But we don't know the value of x. Same like, let's say we have a value of x that is greater than 0. Like for example, if x is equal to 2, for the same problem, this is 1 over x is less than 6. Then we put a 1 over when x is equal to 2 is less than 6, like that. When we cross multiply, you are going to find that it will be 1 is less than, we have 2 times our 6, which will be equal to a 12, like that. Now the fact is that we do not know what is the value of x. Is the value of x equal to 0? Now at some point, x can also be equal to 0. Let's say that our x, when x is equal to 0, we have, for the equation is 1 over x is less than 6. So if x is equal to 0, we will have 1 over 0 is less than 6. Now this 1 over 0 is undefined. Now, due to the fact that we do not necessarily, from first glance, we don't know what the value of x. That's why we never cross multiply for an inequality. We don't know whether this sign should change or this sign should not change. With that said, let us answer the problem. So what we are going to have for this problem is that every time you just make the number cross the sign. So we are going to have 1 over our x. Then we have minus 6 is less than 0. So our x is our lowest common denominator. So we are going to have x is common. X divided by x is 1 times 1. It will be 1 minus our x divided by 1 is x times 6. It will be 6x less than 0. From here, we are going to find our critical values. So our critical values are simply the zeros of the equation. So we are going to say 1 over 1 minus 6x should be equal to a 0 like that. So the zeros of this equation will be such that we are going to have 1 should be equal to, we take the 6x this side, it will be 6x like that over 6 over 6 like that. So our x value will be equal to 1 over a 6 for our first part. We also have this part, the coefficient, the denominator, we also equate it to 0. So our x should be equal to 0. Now let's just approximate what the value of 1 over x. So 1 over x is equal to, or 1 over 6 will be equal to 0. 1 divided by 6 is 0. Points, we add a 0 there. 10 divided by 6 gives you 1. The remainder is 4. Then you add another 0. 40 divided by 6 is a 6. Remainder 4. So it will continue increasing like that. We can even put a 7. The other part is that we also equate the denominator to 0. So we have found our critical values. So just as we were doing in the last video, we had 2 points. Which one is our smallest? Our smallest is such that we have a 0 there. Then we have a 1 over 6 here. So now we ask ourselves, if 0 is here, this means that we could have -1, -2 here. So in other words, all the values that are this side, all the values that are this side are less than 0. So we can say that, let's say those values are x should be less than 0, because all these values that are this side are less than 0. Then let's look at this part of the equation. We can be able to say that all the values of x this side are greater than 1 over 6. Why are they greater than 1 over 6? This is simply because if we have 1 over 6, which is approximately 0.1167, this side we could have 1, we could have 2. So in other words, all the values as you approach this side are greater than 1 over 6, which makes sense for a number line. Now you only use the one that is on the one that is one of your critical values. Then here, all the values that are from here to here, like let's say here, if this is 0, we could have a 0.1 like that. We could have a 0.2 like that. So in other words, all the values that are just this region, it's such that if x is the value, it will be an interval of 0 is less than x. So the values 0.1 is greater than 0. So the values that are there are such that 0 is less than x, but x at the same time is not more than 1 over 6, because that's our boundary like that. So using this, we can use now the table which we were using in the previous video. If you haven't watched it, just comment so that I forward you the video. So using these same values, we are going to get them to say our x should be less than 0. Then we have an interval which we'll put here. 0 is less than x, less than 1 over 6. Then the last will be x is greater than 1 over 6 like that. So if that's the case, we are going to have our factors of the equation are the ones that we use to determine the critical value, which are these. So just getting, not equating them to 0, just getting this part. So we are going to have a 1 minus 6x. Then here we are going to have our x like that. Then here we are going to have a quotient. So why are we having quotient there? This is simply because the result that you get after dividing, we have a 1 minus 6x over x. So the result when you divide is called the quotient. Then from there, we are going to say if x is less than 0, it means that x can take a value such as -1. If x is between 0 and 1 over 6, 1 over 6 was approximated to be 0.167. So the value of x here that we can even use a 0.1. 0.1 is less than 0.16. So we can use that one as our x for the middle part. Then last but not the least, if x is greater than 1 over 6, 1 over 6 is 0.1. So x at this point can be equal to a +1 like that. So with that said, we can now replace. where there is x, we put a -1. So this is the same as having 1 minus 6. Where there is x, we put -1 like that. Then we are going to have 1, -1 times -1, it will be plus. Then we have 6, which is a 7. So this table, we just write the sign. So what it is coming out is a positive. Then we move on. Our negative, if we get our -1, we put it here. It will just be -1. So we are going to write a negative. Then multiply or divide to find the quotient. Positive divided by negative will give us a negative like that. We are here. When we get a 0.1, we put it here. We are going to have 1 minus 6, where there is we are going to put 0.1 like that. So we are going to have 1 minus, so when you are multiplying, this is the same as 6 times 1 over a 10 like that, since we don't have the calculator. So we have 1 minus 6 over 10. So this 6 over 10 is the same as 1 minus, we have a 0 point, we add another 0. 60 divided by 10 will give you 0.6. And 1 minus 0.6 will give you 0.4, which can be calculated like this. So we have something like this. So our 10 minus 6 will give you 4. Then here we have a 0. So we have a 0.4, which should be positive. So at this point, as long as you put it there, it will be a positive like that. Then when we put 0.1 here, it will still be positive. Positive times positive, it will be a positive. Looking at the last one, if x is equal to 1, we are going to have, where there is x, we put a 1. We are going to have something like this. Our 1 minus 6, where there is x, we put 1. It will be equal to our 1 minus 1 times 6 will give us 6, which will be -5 like that. So we are going to put a negative here. Then if we put +1 here, we are going to have a positive value. It will be +1. So we write the sign positive. Negative divided by positive, that's a negative like that. This is what we have as our quotient: negative, positive, negative. Let's now be able to look at our equation. On the factors, it's saying that 1 minus 6x. So we are saying that 1 minus 6x over x is less than 0. So now, they are telling you that the quotient, when you divide this and this, you should be able to get a value that is less than 0. So the only value that is less than 0 is a negative. So in this case, this will be our solution and this will be our solution. So if that's the case, let's be able to put that as our solution. So how we are going to do it is, we just look at the table saying that at this point the interval is such that x is less than 0. So we are going to say x is less than 0, or our x is greater than a 1 over a 6 like that. So if this is what we have, then we are going to write the interval. So if we look at our interval, it is such that our x is less than 0. So meaning to say, if x is less than 0, all the values of x, the lowest value of x that it could take is, let's say, the values that are less than 0 are -1, -2, -100, negative. We can continue with the zeros like that. So now the smallest value that x can take in this case is a negative infinite. We can continue with the zeros, but we'll never reach the negative infinite. So the solution set will be such that we have negative infinity, open bracket, because you cannot reach, so we use an open circle. Then we are going to have comma, a 0 like that. So less than 0, and 0 should not be part of the solution. We are saying that x should be less than 0, so you use an open circle like that. Then where there is O, you are going to use union. Then you have, if x is greater than 1 over 6, it means to say x could be 1, it could be +2. We can just change this: +1, +2, positive. All the numbers continue like that. So the highest you will go is the positive infinite. So we are going to write 1 over 6. Remember, 1 over 6 is not included. We use the open circle, comma, we have some positive infinite like that. So this is how we show the solution set for that one. Let's look at our next problem. Looking at our second problem, we have our x minus 2 over x plus 3 is greater than 0. So, and x should not be equal to negative 3, because if x is equal to negative 3, we are going to have here at the bottom, we have negative 3 plus a 3, which will give you 0. But we never want the denominator to be equal to 0. So immediately you look at this. The first thing is find your critical values. So your critical values are the zeros of the denominator, are the zeros of your equation. So you just get this one and this one, equate them to 0. So the critical values are such that x minus 2 is equal to 0, and you have our x plus 3 should be equal to 0. Then you are going to have x should be equal to 2, or you have our x should be equal to negative 3. So these are our critical values. Now, this being an inequality, we are going to draw something like this. You have a negative 3 here, a negative 3 here, then you have a positive 2 here. Yeah, so negative 3 here. Now, what we're going to do is, this is just a number 9. We have negative 3, we have a negative 2. Then we are going to use the same approach. So all the values that are on the left of 3 are less than negative 3. So we are going to say at this point, all the values of x should be less than negative 3. When you look at all the values going this side, they are greater than 2. So you will say x should be greater than a 2, like that. So if that's the case, all these values, we could have 4, 5, 100, all the values that are this side are greater than 2. Then here it will be an interval. All the numbers between negative 3 and 2 are such that they are greater than negative 3, but they are less than 2, because at this point we could have a negative 2 here, negative 1, we could have 0, we could have 1. All these values are, excluding this, are greater than negative 3, but are less than 2. Let's say the other value is 1 there, which is less than a 2. So this is what we are going to use to draw our table. So using our table, we have our smallest, we have this one. So beginning, we are going to say x is less than negative 3. Then here we have an interval negative 3 less x less 2. Then the last one, it will be our x is greater than a 2, like that. So with that said, at this moment in time, we have, let's say, a value of x that is less than negative 3. X could be equal to negative 4. If you want negative 5 is okay, as long as it's less than negative 3. Then the value that is from negative 3 to 2, what value could be between? We can even use a 1, we can use negative 2, we can use negative 1, any value. So at this point, for the sake of simplicity, we can say x is equal to 0. Now the last one, if x is greater than 2, x could be, let's say, a value such as 3. If you want 4, 5, as long as it's greater than 2. So from here, we are going to now write our factors, and our factors are such that we have our x minus 2 and x plus 3. So we are going to write x minus 2 and x plus 3, like that. Then we are going to put, if we put negative 4 here, it will be equal to negative 4, where there is x minus 2 will be equal to negative 6. So negative 6, we are going to put the sign negative. Then negative 4, if we put it there, it will be negative 4 plus a 3. If we put it here, it will be equal to negative 1. So we are going to have a negative, like that. Our negative times negative, or divide by negative, since it's the quotient, will be equal to positive here. Then here what we are going to have is, if we put a 0 here, it will be 0 minus 2, it will be equal to negative 2. So we are going to put a negative, like that. If we put 0 here, it will be 0 plus 3, it will be equal to positive. Negative divided by positive, it will be equal to a negative if we divide these two. Then if our x is equal to 3, we are going to have a 3 minus 2. So we are going to have a 3 minus 2, which will give us a 1. 1 is positive, so we are going to put positive here. Then if we put our 3 here, it will be equal to a 3 plus 3 will be equal to 6, which is positive. So we just put the sign positive there. Then if we divide positive divide by positive, it will give us a positive value. So now let's see what solution they want. So if we have this, they are telling us that if you divide this and you divide this, you should have a value that is greater than 0. So which value is greater than 0? Any value that is greater than 0 has to be positive. So we have a positive there, we have a positive here as well. So what we are going to do is we are going to say that our x is less than negative 3, or because this is the one that is giving us positive, then or we have another one that is giving us positive as our x is greater than 2. So now if x is less than negative 3, meaning to say the solution set will be such that we are going to have open brackets negative infinity. That's the smallest value you can go. If it is less than negative 3, it means to say the value of x should be equal to negative 4, negative 100. It could continue negative 1 billion and all that. The zeros could keep increasing, meaning to say the smallest value of x is a negative infinity, and going to the same value, which is our negative 3, open circle, because it is not it's just x is less than. Then we are going to say all means union. Then we are going to have, if x is greater than 2, we could just change the signs here to positive, positive, positive. So the values that are greater than 2 are such that we are going to have values such as a positive 4, positive 100, 1 billion, whatever, 1 trillion. The values can be able to increase like that. So we are going to put a 2, then we are going to say comma, we have our positive infinite. That's the highest value of x that you can use. Then use an open circle to show that it's not included because it's infinite. Let's look at our last problem. So for our last one, we have this problem. So same approach, we take the 3 the other side. So we are going to have our x squared minus 7 like that. We have over x minus 3. The 3 crosses the equal sign. We have minus 3 like that. Greater than or equal to, we have a 0 if the 3 crosses that sign. So take note that x should not be equal to 0, or should not be equal to 3, because 3 minus 3 will give you 0, which is undefined. So now with that said, we are going to say that so that condition is very important for our final answer, because of the less than, of the greater than or equal to. We are going to use it wisely. So from here, what we are going to do is we are going to find our lowest common denominator. Here it will be our x minus 3 like that. Then the value on top will be just the same one, x squared minus 7. Then we have negative 3. So we have first x minus 3 divided by 1. It's just this one. Then we multiply it with this numerator. So it will be negative 3 open brackets x minus 3 should be greater than or equal to 0 like that. So we are going to end up with our x squared minus 7. Negative 3 by x will be negative 3x. Negative 3 by negative 3 will be positive 9 like that. Then we divide this over our x minus 3 should be greater than or equal to a 0 like that. So by doing this, what we end up having is the situation of our x squared. Negative 7 plus 9 will give us positive 2. Okay, let's begin with the one with x. So we have this one is just alone, minus 3x. Negative 7 plus 9 will give us a positive 2 like that. Then we divide this over our x minus 3. Then we have greater than or equal to 0. So the numerator, let us be able to factorize this one. So factorizing this one, we are going to have our product. In this case, for the one on top should be equal to our AC, in which one A is 1, then C is 2. So 1 times 2 will give you 2. Then we have our sum for this one will be equal to a B, which should be equal to, just the coefficient here is negative 3. Then the factor the two numbers which when you add them, they are going to give you -3, but when you multiply, they will give you a +2. Those values are a 1, a -1, and a -2. So if you add this, they will give you this. If you multiply them, they will give you that. So with that said, we can now replace them in the original equation. So we have an x squared. Now where there is 3x, we are going to say minus our x minus, we are using those, minus our 2x. We haven't changed the meaning. Then we have our plus a 2 greater than or equal to 0, like that. So then we have over, we have our x minus our 3, like that. So with this done, we can factorize the top. We are going to have our x minus, if x is common, just here, we are going to have our x, open brackets, x minus 1, like that. Then even here, we factorize. Here, what is common is a -2. If -2 is common, we are going to remain with just x. Then 2 divided by -2 will be -1, like that. So this should be greater than or equal to a 0, like that. Then we divide this over our x minus our 3. So this bracket is the same. So we are going to end up with our x minus 1, like that, and our x minus 2, like that, should be greater than or equal to a 0. Then we are going to have over our x minus 3, like that. So we have factorized the top part. The next thing that we need to do is we are just now going to use a table. So before coming up with a table, let's find our critical values. So our critical values are the zeros of the equation. So the critical values, we equate each of these factors to 0. So we are going to say our x minus 1 should be equal to 0. We also have our x minus 2 should be equal to 0. We also get the denominator equated to 0. So we can also have our x minus 3 should be equal to 0. So x for the first one will be 1. We take that side, it will be x is equal to 1. Here we are going to have x should be equal to, when we take the 2 this side, we have x is equal to 2. Last but not the least, x should be equal to 3 here. So if these are our critical values, let's use the number line to come up with the interval. So these are our critical values. The first one is our x is equal to 1. Let's just put it somewhere here. We have our x is equal to 1. We also have our x is equal to 2. We also have our x is equal to 3. So we have 4 regions. We have this region, this region, this region, this region. So all the values that are on the left of 1, you will find that your x, at this point, it will be your x is less than 1. So all the values that are this side, they are less than 1. We could have a 0 here. We could have -1. So in other words, as long as you are moving to the left, all the values are less than 1. So x is less than 1 at this point. Then here, the numbers between 1 and 2 will be such that it will be, let's say if we have 1 here, we could have a 1.1, we could have a 1.2. The middle part, we could have 1.5, like that. So all the values that are in between this are such that they are greater than 1. So x is greater than 1, but less than 2. Because if you look at 1.1, it's greater than 1, but they are less than 2. The highest, let's say, for example, it's 1.9, which is less than 2. So these are more like our boundaries. We have another interval from 2 to 3. What we are going to have is a 2 is less than x. X is less than 3. So the interval, we could have 2.1, we could have a 2.5, like that. We could have a 2.9. So all the values are greater than 2 but less than 3, like that. Then the last interval will be such that all the values of x are greater than 3. So values that we are talking about are values such as 4, 5, 6, 7, up to some positive infinite. So with this said, we can now be able to come up with our table. So what we are going to have is, we are going to write our intervals. So the first one is our x is less than 1. The second one is an interval of 1 is less than x is less than 2. The third one is a 2 is less than x is less than 3, like that. The last one is such that x is greater than 3. So when x is less than 1, it could be x that is equal to 0. So a value that is less than 1 could be 0, it could be -1, whatever value you want to use. Now from 1 to 2, so here as you can see, between 1 and 2, the values that could be there are 1.1 there. So let's use, what values do we have? So let's fill in first our factors. So we had, our factors are x minus 3, x minus 2, and x minus. So we have factors which are our So now, according to what we have, our brackets are saying that x minus 1 and x minus 2. So these are multiplying. So the result on the third one, we are going to say product. Then we are going to write another factor, which is the denominator, which is our x minus 3. So we are going to put our x minus 3 there. Then when you divide the product, divide by this, now it will become your quotient. So with that said, we are here now. So the value that is between 1 and 2 can be, we have these values 1.1, 1.2. So let's just use a simple one. We can say that x is equal to 1.1. 1.5 is also okay. So let's use 1.1 like that. Then we are here. The value between 2 and 3 can be a 2.1. If you want 2.5 is okay, 2.4, 2.3, anything. So then the last value, which is greater than 3, if x is greater than 3, x could be equal to a value such as a 4. So with that, we can replace, if we put 0 here, it will be 0 minus 1, which will be -1. So we are going to put a negative. If we put 0 here, it will be 0 minus 2, which is a negative, like that. Then if we have negative divided by negative, it will be a positive, like that. As we move on, if we put a 0 here, it will be 0 minus 3, which is a -3. So it will be a negative here. If we divide our product, divide by this negative to get our quotient, we are going to have a negative, like that. So we are here. If we put 1.1 here, so we are going to have 1.1 minus a 1. 1.1 is greater than 1. It will give us 0.1, which is positive. So we are going to get a positive here. Then 1.1, if we put it here, we are going to get a negative. 1.1 minus 2 will give us a, since 2 is greater than 1.1, it will give us a negative 0.9. So that since it's negative, we are going to write our negative. Then we are here. If we divide, positive divide by negative or multiply to get our product, we are going to get a negative. Negative times positive will be a negative. Then we are here. If we put 1.1 here, we are going to end up with, if we put 1.1 here, it will be 1.1 minus 3, which shall be equal to negative 2.9. So we are going to have a negative here. So negative there. If we put 1.1 minus that, it will be a negative. Then product divide by this to get our quotient. Negative divide by negative, it will give us a positive, like that. Then when we look at our 2.1, we put it here. It will be a positive because 2.1 minus 1 will give you is a 1.1, which is positive in that case. If we get this 2.1, we put it here. 2.1 divided by 2 minus 2. 2.1 is greater, so 2.1 minus 2 will give us a 0.1, which is positive. So we are going to put a positive. Positive times positive, we are going to get a positive, like that. Then for our third one, if we put a 2.1 here, we are going to get a negative because 3 is greater. If we put 2.1 here, if we put 2.1 here, we are going to get a 2.1 minus 3, which is going to give us a negative 0.9. So if that's the case, we are going to put our negative there. We divide this divided by this, we are going to get a negative like that. If that's the case, we have this. Let's look at our last portion. If we get 4, we put it here, it will be 4 minus 1, which will be equal to positive 3. So the sign will be positive. If we get 4 minus 2, it will be 4 minus 2 will be positive. 4 minus 2 is positive 2. Multiplying positive, multiplied by positive, it will be a positive there. Then we have our x minus 3. Since x is equal to 4, when we get this 4, we put it here, it will be 4 minus 3, which is positive 1. So we are going to write a positive. Then our positive divide by positives to get the quotient, we are going to get our positive like that. If this is the case, let's see which solution we are going to take. So what we are going to do is, we have been told that the result, if you divide the products of this divided by this, you should get a value that is greater than 0. So in this case, the one that is greater than 0, what we have is this one and this one. The sign positive is greater than 0. So getting those as our solutions, we are going to get our interval, which is this one. It's saying that 1 should be less than x less than 2 like that. Now the fact that there is greater than or equal to means to say we can include, so we can say this. We also have or, we have our x this side. So your x here is such that x is greater than 3. Now take note that we are not going to do this because x is equal to 3 should not be part of the solution, because if we say that x is greater than or equal to 3, this is wrong because we are assuming that one of the x values could be 3, and if we put 3 here, it will be whatever is on top, it will be 3 minus 3, which is a 0. Now whatever number you have divided by 0 is undefined, so you need to just be careful there. So we can have this as our solution. Now writing this as our solution, your value of x is from 1 to 2, so we are going to use our square bracket, then we use 1 and we put a 2, another square bracket, then all means union, so we are going to say union of our x is greater than 3, so the smallest will be 3 with not included, so this bracket. Then if x is greater than 3, the highest value will be a positive infinite like that. So this is how we do that. Thank you very much for watching the video. Hope you would like, subscribe and share for more. See you in the next tutorial.